Today we are going to continue our discussion on the different types of data available to us through C#. We've talked about classes, interfaces, and enums, and today we are going to talk about structs. Structs are a lot like classes, and in fact, whenever we use structs within our code, it's going to look almost exactly like the usage of a class. But there's one key difference between the two. Structs are value types. They are stored by value, as opposed to classes, which are reference types. But even then, we could write a struct almost exactly like we would a class. But the question is, would we really want to? And in order to answer that question, we have to talk a little bit about memory management. Now, we have briefly talked about memory management as far as value types and reference types, but we haven't talked anything deeper than that. And now is just as good of a time as any. Memory is divided into two different pools. The first pool is the stack, and this is where value types are stored. The other pool is called the heap, and that is where reference types are stored. The heap starts at an initial value, and then memory is dynamically allocated as we need it. So the heap is extremely flexible in that we can store a lot of data on the heap. But the stack is fixed size. Whenever we run out of stack memory, we have run out of stack memory. And in fact, we can overflow the stack memory, which is where the term stack overflow comes from. So naturally, whenever we define a value type, which a struct is, we want to make sure that we are using as least amount of memory as possible, because once we use up the stack, that's it. And let's look at a perfect example of a struct. It's one in the .NET framework called datetime. It represents date and time. And I say that this is perfect because all of the underlying data within the datetime struct are numbers. So everything is going to be on the stack, and they are going to be relatively small. And I said earlier that structs are a lot like classes, so we are going to see a lot of the same syntax. And one such syntax is a static property. So the datetime.now gets the current date and time of whenever this line executes. So whenever that happens, that value is going to be assigned to the now variable, and then we can use that data to perform whatever time calculations that we need to. Datetime is also immutable. So that means we cannot modify the value of now. We can, however, take that value, add something to it, and assign that new value to another variable. So let's do foo. And then we have different methods that we can add days or hours or months or years. Let's add a year. And so we've essentially added a year to the datetime value that we've had, and we store that new value inside of foo. So I'm recording this on a day in January in 2012. So this would be the same day, but in 2013, at least what is assigned to foo. There's also a property. Let's find it, day of week. If you'll remember from yesterday, we looked at the day of week enum. So today is Wednesday or Tuesday for me. So if we did this comparison, this would be true. And we can create datetime values using a constructor. So let's do new datetime. We can use the overload to specify the year. Let's do 2001, 6 for the month, 9 for the day. So the date contained within bar is June 9th of 2001, but we didn't specify a time. So the time defaults at midnight. But if we wanted to do so, we can use another overload. We could specify the hour. This is on a 24-hour clock. So for 1 o'clock p.m., we would do 13 minutes. Let's do 0, and second, we'll do 0. So now the bar variable contains the value of, or at least representing, the date and time of June 9th, 2001 at 1 o'clock p.m. So I apologize for sounding like a broken record, but this just proves that structs are a lot like classes. We have constructors, we have properties, we have methods, we have everything that a class has, but there's just one defining feature. Structs are value types. So with that introduction out of the way, let's write our own struct, and we will do so to represent colors for our shapes. So let's create a struct class or a struct file. If we go to new item, we aren't going to see struct listed here. That is unfortunate, just like the enum was unfortunately not there. So we are going to have to create either a class or an interface. I'm going to do a class. I'm going to name it color, and then we will need to change class to struct. I'm also going to add public, because why not? So we need some properties for our struct. We need red, green, and blue properties. So let's use the shorthand version. These are going to be of type byte. Byte is a primitive data type, and it has a range of 0 to 255, which is perfect for our numbers. And this property is going to be called R for red. We'll do the same thing. Well, let's set this as private as first. We might want to change that later, but it doesn't hurt to be protected at first. We have RGB properties already set up. Let's create a constructor to set those values. So byte red, byte green, byte blue. Then R equals red, green, or G equals green, B equals blue. Very redundant, but oh well. Oh, and there's one rule about structs that we unfortunately have to follow. That is, a struct cannot have a default constructor, or at least we cannot write the default constructor. If we try to build this, we are going to get an error. And if we look at the error, structs cannot contain explicit parameterless constructors. This is a limitation of C#, not of the .NET framework. In fact, the .NET framework, whenever we compile our code, it's going to generate a default constructor for us. Like, for example, datetime. We can create a datetime object with a parameterless constructor. That's because the compiler did it for us. So the compiler can do it, but we can't. That's not fair in that way. Okay, so we have our properties, we have our constructor. Now let's have some static properties to create some color values for us, like red, green, blue, and black and white. We just might as well go ahead and do everything. So let's do public static color. We'll start with red. This is going to have a get accessor, and it's going to return a new color. We just need to specify 255 for red, 0, and 0 for green and blue. And that is red. Static color for green is going to look very similar, but instead we pass 0 to red, 255 to green, 0 to blue. Blue, color blue, return new color 0.0255. We're almost done. Let's have black, static color black. I can't type under pressure. I can type just fine in my office or when there's no recording equipment going, but put me under pressure and I start typing typos left and right. Okay, so last thing, static color, not const, color white. New color, and that is 255, 255, 255. And whew, we're done with our struct. So we have our properties, our instance properties, then we have our constructor to set those instance properties, and then we have some static properties to easily create some colors for us. Now, I didn't mention it before, but in the .NET framework, there is a color struct, and it doesn't look exactly like this, but it's the same basic idea, except there's also an alpha value that we could choose as well, but I just wanted to keep things simple. So we can use this within our shape class by setting a new property. So we can have public virtual int, well, or I'm sorry, not int, color, And then we will call this color as well. We can have a property name that is the same name of a data type, just so that you know. We want to get return underscore color. We haven't created that yet, but we will soon. And it's kind of iffy if we want to be able to set that. I don't know. We'll leave it as protected for now. So color. And so now we need to add this ability to assign a color through the constructors for our square and circle. So we need to add a color and then assign that color. So color equals color. We need to do the same for circle. Underscore color equals color. And there we go. We have created a struct that represents a color, red, green, blue values. And now let's use it. Okay, so we'll go back to program.cs. Let's get rid of all of this code. And let's create a square. Equals new square. Let's give it a length of 10. And we can use, either of these, black, blue, green, or red. Let's do red. Why not? Let's also create a circle, just for completeness. It'll have a radius of 10, and it will have a color of white. Now you might be asking yourself, when should I use a struct and when should I use a class? Well, the answer to that is it depends. It depends on the data that you want to store within that struct or that class. In the case of our color struct, we are consuming 3 bytes, one for red, one for green, one for blue. So that is extremely acceptable for a struct. But if we wanted to store a lot more data, then naturally we would want to use a class. But the general rule of thumb is, when in doubt, use a class, because classes are slightly slower than structs. But when it comes down to it, I would rather have something that's slightly slower than something that crashes because of a Stack Overflow. So when in doubt, use a class.